What's really cool about that is that if your UI active elements are delivered with the content, the UI elements can change like on every request. I ended up, one of the ironies of life. I'm teaching the class that caused me to drop out of computer science at Berkeley. And I have a much better understanding of how computers work sort of at a fundamental level because I just had to learn it to teach it. When you've got like a really unstable library, you can like wear like black turtlenecks and be like Vercel and like super well produced. But when you have a very stable library that doesn't change, you have to act like a lunatic to get any attention.
So let's start maybe on your background. How did you get into programming in general?
I was very lucky because my parents were they were well off enough to like get me a computer as a pretty young kid, and they actually got me some programming lessons. I didn't really understand it, but I learned how to program in Apple Basic, which is like on an
Nice.
old Apple II or whatever. And I didn't really understand what I was doing, but it was a little bit of a chance to get into computers, and then we became a Mac family eventually, and the Mac had something called HyperCard on it, which is an old programming environment, very unique and interesting programming environment. And it was sort of like the web before the web. There was no network really involved unless you used plugins, which I didn't understand any of that stuff. But you could make sort of there was a notion of hyperlinks between these things called cards, and then there was a scripting language called hypertalk, I think. And that was like my first real experience of like making computers do things with a programming language. And so then I did some pretty like not serious work, but like work for friends to make real programs in HyperCard. And then I went to college and I thought I wanted to be a computer programmer. And I went to Berkeley, and I found out just how good real computer programmers were, and I was not ready for Unix. Like you can imagine this Mac kid sitting down at a blank screen with like this gray screen with an X on it, and this mouse has three buttons. I don't know what I'm doing. And so I was pretty intimidated by that environment, and I ended up actually dropping out after about, I think, 2 years. I was just like, I can't do this. And I ended up switching to industrial engineering, which just kind of interested me. But by the end of my college career, I was programming again a whole bunch. I actually picked up Visual Basic and Excel. So Excel has a Visual Basic engine in it, and you can do a lot of really cool stuff with it. And so that was super useful for industrial engineering. And then when I graduated, that was kind of like right at the end of the dot-com boom. And so I ended up getting a job as a programmer in the Bay Area. I was in the Bay Area, and there wasn't a lot of industrial engineering jobs, but there were a lot of programming jobs. So I picked up, and Java was the big thing then. And so I really picked up Java, and I kind of went back and like relearned, like really learned how to program because I never, at Berkeley, like the language that you start with is Scheme, which is
Yeah.
insane. And, and then and so I didn't understand that at all. And then they immediately go to like C++, which is also like just a bad thing to learn how to program with. So I felt like I never learned it. So I really taught myself Java after I graduated. And then I went back to grad school. I got into programming languages after undergrad. I kind of figured out what was going on. I did a lot of reading on Lisp, and I got into programming languages sort of as an idea. And so I went back to graduate school at Stanford in computer science to kind of address what I felt was sort of my failure as an undergrad to finish up in computer science. So I got a master's in CS from Stanford, and then kind of after that, I just kicked around in the Bay Area for a while, working in sort of very like Bay Area type companies doing,
What does it mean?
yeah, that means whatever you want it to mean, but definitely very Bay Area. So it was good. I interned at Google for a little bit, kind of screwed that up by pissing off my boss. I tend to be a little, if you're familiar with my online presence, I tend to be a little
Yes.
irreverent, and some people like it and some people don't. My boss at Google did not. Um, and I eventually ended up moving. I grew up outside Sacramento, which is in sort of like Northern California. It's north of San Francisco, more towards the mountains. And so I moved back there with my wife, who is also from that area. And then about 6 years ago, uh, my company blew up. I had a pretty good little SaaS company that was going pretty well, but my co-founders couldn't get along, and so they sort of forced the sale of the company. And I was sort of sick of everything, so I moved to Montana, which is the equivalent of like nowhere. It's very beautiful here, but it's like the middle of nowhere for most people, and it's very cold in the winters, especially. So I moved out here, and I took a job teaching at Montana State. Teaching computer science here. I just was like ready for a change. And so I ended up moving out here. And so I've been out here now for almost 6 years. And so that's how I ended up here. And that's how I sort of got into programming.
How do you find teaching?
Teaching is really good. It's been great for me. Like you don't learn stuff until you teach it, you know? Like trying if you need to learn something, teach someone else about it because I understand how computers work a ton better. I ended up one of the ironies of life. I'm teaching the class that caused me to drop out of computer science at Berkeley. And I mean I have a much better understanding of how computers work sort of at a fundamental level because I just had to learn it to teach it. And so they gave me that class. I think no one else wanted it, and now it's one of my favorite classes
What's the
because
class? What's the
it's
class?
called it's 360. It's systems. So you basically start with transistors. And the way I teach it, anyways, is I start with like, here's how a transistor works, and like, okay, here's how you can make an adder out of transistors, and
Okay.
here's how you can store a bit with transistors, and then okay, now like, what does an instruction do? And there's a really good, I think, model of a computer called the Scott CPU. You can look that up. The book is called But How Do It Know? It strikes some people as being anti-intellectual because it's pretty simplified. It's like a simple 8-bit computer, but it's a very simple CPU. And I think for most developers who aren't doing architectural work or assembly work, it's a really good way to understand like here's how an instruction kind of marches data around a CPU and so forth. And then we sort of go up from there. Okay, like here's what a machine instruction looks like, and here's kind of what it does and how it moves data around in the CPU. And then okay, now like what's a compiler? Okay, let's look at what or I guess what's assembly first, like assembly one-to-one translation with machine code, and then this kind of stinks to program in. So like what's a C compiler? What a C-like compiler look like? We're actually working on a new. One of my core beliefs as an educator is that people need visual. They need visuals. And so we're building a visual computer. It's a 16-bit computer, so a little bit more capable than the Scott CPU for students to really learn how sort of low level computing works, like bit masks and like, poking memory and like what a pointer really is and so forth. So
But
yeah.
visual meaning what?
It's visual meaning like shoot, I wish I could show you a screenshot, but basically it's like it's a web page, so they don't have to install
Okay.
anything. They just run this program and it starts a web app. And the web app is an emulator in the background. And then the web app is like the registers are like in the upper left corner, and they have like red like blinking lights. Like one
Mm.
of the things I think that like the older generation had that we don't have as younger people is like everything's so damned complicated now that you don't
Yeah.
get that like visceral connection with it that like the old 1950s computers where the lights were blinking and you could see the program like jumping around and all that stuff. And so we're trying to like recapture that visual sort of like, hey, like this is what a binary value looks like in like LEDs like on a screen. And like if you do like an XOR, like here's what happens, and you can sort of poke and prod it and do it all visually. So trying to mix together like sort of modern stuff that's really nice, like modern visual debuggers with this like old school, like sort of visual feedback so that students get a better sense of like how the computations work and all that sort of stuff. So we're
Nice.
working on that, hoping to use that's going to be in the next rev of that systems class. So it's a big
Okay.
project this
Yeah.
summer.
How do you get from here to HTMX?
I don't think you do. How did HGMX? So I was a web developer for a very long time. Like that's what when I said, I worked at standard Bay Area companies. Almost all my work in the Bay Area was at least involved a web application, if not directly working on either the web application itself or infrastructure for web applications. I did do some like sort of pure back end work at times, but I've always just been doing web apps. And I got the startup sort of after when I was in Sacramento, the startup that I was working on was a Rails based app. And so that really like, what do I want to say? That really firmed up my understanding of the web and like what a web app is and how simple it could be. There are aspects of Rails I think are a little weird and magic, but that's just the flavor of Ruby and Ruby on Rails, which is fine. So, but that really opened my eyes. Like it didn't have to be this crazy, I was in the J2E world for a long time. And so like that world is very complicated. Like
Oh yeah.
there are many abstractions between a web request and like doing something. And all that stuff to an extent got stripped away in Ruby on Rails. I never did PHP, which I think is even more of a like there's just nothing between the request and the response in that world. But I just never did PHP work for whatever reason. But Rails, I feel like let me get away from these like very high level abstractions and just realize, okay, it's just a request and a response. And when I was doing work on that Rails app, that was like in the like around 2010 ish timeframe. I was, that was right when Angular was like the first big SPA framework that sort of like took the world by storm that I remember anyways. There were ones before that. There was XJS, which I don't know if you've ever heard of XJS.
No.
It's still around. It was a commercial kind of like React before React thing. And we'd used that at the company that I worked at before I did my Rails project. And it had left a very sour taste in my mouth because it had been very complicated. And this was using JavaScript, like, back when it was real bad. That had left a pretty sour taste in my mouth. And then I saw Angular 1, and I think everyone at this point kind of agrees Angular 1 was a little bit of a mistake as far as like the abstractions. But I just was like, I'm not doing that. And I was using jQuery like everyone else in the world in 2010. And jQuery has a method called load, I think. I think it's load, jQuery.load, that'll just issue a request and then load the response into an element. And I was doing web development and I was working on a table that needed to get sorted. And I was trying to do it client side in JavaScript using just the DOM because there was no model or anything like that at the time, beyond just what the DOM. So I was trying to sort it and it was taking forever and I was running out of tricks on the client side. And I saw this load method from in jQuery and was like, I'll just try that. I'll do the sort on the server side and then just slam the thing into the DOM. And I did that and it worked. And it was like super fast and awesome. This is 2010, so the JavaScript runtimes are really bad and inconsistent and so forth. And it worked great. And I was like, dude, what? You can do that? I didn't know you can return HTML like to an AJAX call. Like I didn't know you could do that. And so I saw that, and then so I started using it everywhere because I was like, I can do this everywhere. And then I realized like you can just use the normal jQuery AJAX function, but then, get back HTML and then you can start doing even more complicated stuff. Like you can issue a post or a put or a delete or whatever. And then you can put it anywhere. And then I didn't like Angular 1, but I saw the way you use attributes to drive behavior. And I thought to myself, one of the bad things about jQuery was that you ended up putting all of your behavior in a JavaScript file, like somewhere else.
Yeah.
And that always bothered me because when I look at an anchor tag or a form, I'm like, oh, it does this. Like I know what it does because it's right there on it. And so I wanted to capture that same what I would call today locality of behavior, that locality with this new toy that I had found. And so I started using attributes to like hook this function would look in the DOM for certain attributes and then hook in the functionality based on those attributes. And it just sort of organically evolved into me realizing, okay, this is a lot like forms and links, and I'll just make it a standard and I'll use CSS selectors because that's how everything works anyways. And that grew into it grew into a library called intercooler.js. And so I was using intercooler.js on this Rails startup just internally. I released it. It got somewhat popular. I mean, I think it has like 4,000 or 5,000 stars. So, like people noticed it for sure. But then when COVID hit, I was like, what, 2019, 20, I forget at this point, whenever that was. I decided rather than like watching the news and going insane, I would just lock myself in my office. I was still in California at the time, and I would rewrite intercooler JS without the jQuery dependency, because that jQuery dependency that like had just persisted for into intercooler JS. And JavaScript has gotten a lot better and a lot more standardized over the decade that I've been working on intercooler, and so it turned out that it was pretty easy to do, and so I redid it and renamed it to HTMX and then re-released it, and then just kind of, made some progress. Some people picked it up, and then all of a sudden, about a year and a half ago, I guess now, Primagen and the Fireship dev both picked it up like in the same week, and it happened to be like it was crazy, and it happened to be the week we released the book Hypermedia Systems, or like right
Oh,
around there. I
really?
think I think we released the book like 3 weeks later, so it was like the perfect marketing. It was just perfect storm, like two guys talking about this, and they're like, "Oh, where's the book? The book's coming. Everyone's excited about the book." And then we released the book into huge amount of publicity, and so I just caught a wave there, and got pretty lucky with that, and that's how HGMX ended up where it is today, as far as I can tell. That's that's my version of the story, anyway. So
Nice, nice.
yeah.
Uh, could you do like a little bit of summary? Because in your book, in the chapter one,
And
and the first part, really, you make this sort of like a sane overview of the insane state of the web today, and it really helps to portray why HTMX is so cool and important. So could you do this a little bit for all the people that are like more maybe game dev oriented in the audience,
right.
but
Yeah.
also have like memories of doing some stuff probably with like HTML, and then
Right.
it got all reacted and like
Yeah.
it's lost.
Yeah, well, I don't want to be too judgmental. There are reasons to use like, reactive style programming for sure. So, but I do think it's kind of an interesting situation that we've gotten ourselves into, because the web was built on hypermedia, obviously. Like that's the fundamental technology of the web is hypermedia, and like the hyperlink and then the form tag, which came along in HTML2, and which turned the web from a read-only hypermedia system, which the majority of thinking about hypermedia was really more oriented towards read-only systems. Like it was more about navigating and like maybe tagging things, but it wasn't so much this like update. There wasn't a notion that like, oh, we could build apps with this, or not, at least not as strong as like this document focus that the web still has to an extent. When people talk about like web pages, like, so so historically, though, the web was this hypermedia system, and hypermedia is actually a pretty interesting concept. The idea of hypermedia, the core idea, I think, of hypermedia, the core practical thing, technically interesting element of a hypermedia system, in my mind, is what are called hypermedia controls, and those are links and forms in HTML. Those are the standard hypermedia controls that people think. Those are the user interactive ones, anyways. And those are, what's interesting about those things is you embed them in a broader document, right? Or in a broader, like there's information and styling and like structure and all this stuff. And then you have this little thing sitting there that's like this little piece of magic that says, okay, when this thing gets clicked on, I want you to do something crazy. I want you to go to like some other URL, issue a get to it, and then load the content into this browser window. Or, with a form, I want you to submit these values somewhere and do something. And that idea of hypermedia controls, it's a mixing of concerns. So one of the ironies, I think, of web development is one of the big ideas in web development is separation of concerns. And that came along later. But like if you look at the web from first principles, it's really a mixing of concerns, because you're mixing control information like user UI elements, if you like, or even more complicated, like distributed UI elements, directly in this alongside the data and the styling information that you're presenting to the user. And you've got these crazy sort of magic clients called web browsers that can take those controls and then do something interesting with them. And so this core idea like of hypermedia, what I guess what do I want to say? Like, I don't want to get too nerdy, but like what's really cool about that is that so if your UI elements, if your UI active elements are delivered with the content, then what's cool about that is the UI elements can change. Like on every request, every remote request you make, you get back a new sort of like user interface. And that's in contrast with thick style applications, which typically work with like a fixed data API. And so, like, if you're used to JSON, then you're used to interacting with a fixed JSON API, right? You're used to, oh, my alarm's going off. Sorry. Just give me 1 second. Can you hear that?
Okay. Yeah, yeah, yeah.
Hold on. We'll cut
Do,
this.
do you think it will stop?
Yeah, it's
Okay.
stopped. Okay. So reset. So if you're used to JSON style applications, then what you're gonna do is you're gonna issue a request and you get back just data. And your front end, it may react to like some of the content in there, but you're not streaming back new user elements. Because like with a hypermedia based request, you can't get back a totally different UI. Like just depending on the state of the world, you can render a completely different UI. And so that makes hypermedia systems very dynamic and flexible when compared with what I think they should be compared with, which is older fixed data API style systems, RPC style systems that were built in like in the 80s. That's what you did. You built these thick clients and they talked over Corba or something like that to the back end. So there's this whole like history, right? And like the web grew gangbusters and it was super flexible and you had this crazy like magic browser that knew how to talk to banks and like car dealerships and like your bank, like the grocery store and like like all these things, like you know how to do everything because it just communicated in what is from a technical perspective called the uniform interface of HTML or hypermedia. And that was super flexible. I think the web, you can very strongly argue, is the most successful distributed system in history. And that hypermedia, that those aspects of hypermedia were crucial in that. And then, sorry, this is going to be a long story, and then what happened was people got sick of the clunkiness of Web 1.0. So if there was one bad thing about Web 1.0, and people noted this back in even the late 90s, compared to thick applications from the 80s, the web felt kind of clunky because you had this full page refresh every time you did something and you lost your focus state and the scroll state reset and all this, like a dinosaur came out and did a cartwheel or something and all this like crazy stuff that was going on visually. And that didn't compare well with some of the more polished thick applications of the past. And then when mobile, and I think this is a big part of the story, when mobile came out and mobile adopted a lot of the ideas of the thick client world, right? Like you had an app and the app talked over a data API and it was much more polished and smooth and you swiped and it slid and like all this stuff. I think that put a lot of pressure on the web. Like, wait a second, like the web isn't that, and like that looks better. I remember for a while people were like, mobile's going to kill the web. And it's like, yeah, maybe, but probably not going to happen. At this point, I think the web is safe, but that did put a lot of pressure on the web. And so Google Maps was really the first one that I remember. People started building these applications using that approach, that dumb data, but like very rich and interactive front end experiences, that style of app in the web using JavaScript and using JSON, what emerged as the JSON standard for data transport. And there were just incredible apps. Like when Google Maps first came out, it was incredible compared to like MapQuest, where you had to like click an arrow and it like ka-chunk and it went to the next thing over. It was horrible. Where it's like you're zipping and zooming around in Google Maps, and it's obviously a better approach for that particular problem, anyways. And eventually, React came out, and that was being pushed by Facebook, kind of like right at the peak of Facebook influence on the internet. And so a lot of people picked that up. And I'd say that's become probably the standard at this point. Like most people, when they think I need to build a web app, think to themselves, I need to use something like React. And I don't begrudge that. They're environmental and like hiring's easier, and there's lots of libraries and the tooling and all the rest of it. So I don't begrudge people who say that, but I do think it's unfortunate that we've lost this notion of like what hypermedia was and also what it could be. And so that's where I think HGMX like comes into this story is it's gone back and said, okay, can we address the shortcomings of hypermedia, get some of the advantages of hypermedia back, like the simplicity, you don't have state, in three places, or you only got it in the back end and the DOM at this point. But still satisfy the interactivity needs of sort of modern web applications. And I hope the answer to that is yes. I think most reasonable people would say yes. Like you can use HTMX to make web apps sort of like we used to, and they're more interactive than they used to. Where I think a lot of the disagreement is like just where exactly that line is. Like at what point are you going to have to kick HTMX out and use something like React to achieve the user experience that you want? And so that's I think where for reasonable people, that's what the argument is about. It's like, okay, how much? And I do you can, just like with any tool, you can get pretty crazy with HTMX and start getting very complicated, and it's like, okay. Like at some point it might be better to just adopt a reactive solution to this. But I think that line, I hope, I think most reasonable people would agree, has been pushed significantly. Like, web 1.0 applications kind of stink, although they've gotten much better. Browsers have gotten much better at rendering. There's now like page transition APIs and all this stuff you can use. But HGMX takes it even further where you can do more using the hypermedia approach, and then you get all the advantages of that approach. And most importantly, I think the simplicity of it. So
where would you put the line? Where would you say that like, okay, this is not in scope for HTMX because it
yeah,
requires too much reactivity?
I would say like the examples I typically give are Google Maps would probably not be a good thing. I think it would be doable, but you'd be working pretty hard. Um, but then like Gmail, in my mind would be perfect for HTMX because it's just text and it's text boxes and lists and like whatever. It wouldn't be good for an offline situation. So if you need offline behavior, that's like something that HTMX, one of the downsides of hypermedia is that it's a distribute, it's built for distributed systems. And so it doesn't handle offline situations well. Like that's not a way that's just not an area it's designed for. I think the more sort of cruddy your app is, like if the value is derived from logic that's being executed on the back end, and it's more just lists of things and searching and slicing and dicing and stuff like that, then that's where HTMX really shines. Text and images, sort of the bread and butter of the web. And then when you start talking about like dealing with like mouse clicks and like drag and drop is very like there's an example on the htmx.org/examples webpage of drag and drop using a JavaScript library, which it's fine to use JavaScript with HTMX. It's just there's a certain style of JavaScript that you write where it's more DOM oriented instead of having a model and all that stuff. So you can use drag and drop with HTMX, but if you need to have like I wouldn't do like Figma obviously or something like where like mouse events are just absolutely crucial to usability. Like I don't think HTMX is a good fit for that. But even in those apps, I think HTMX could be fine for like the settings page, which is what just a list of like controls, and you want to click save and update them. Like that's something that HTMX would be useful for. So maybe you could use HTMX there and save some of that complexity for where it matters in your app for another area. So I don't know. I don't quite know where the line is. I've seen people do really crazy stuff with HTMX, and I'm like, that might be a bit much, but but I've seen people do some pretty crazy stuff with it. I'm always a little, I'm just waiting for that. There's going to be a blog post where someone's like, we went all in on HTMX and our company went bankrupt. And I'm like, oh man, that sucks. We kind of had that. The Gumroad guys tried HTMX and they didn't like it. And they actually contributed an essay to I put it on the HGMX website. If you go to htmx.org/essays, there's a on the other hand section,
Okay.
and the Gumroad CEO, whatever his name, Suhil, I think, whatever his name is, he wrote an essay on their experience with HGMX. They ended up not using it, so.
But I'm assuming it's constructive feedback.
I think so. I like when I look at it, I see JavaScript developers trying to like hammer HTMX into like a JavaScript framework. That's what I see, and so I would have been like, well, okay, can we make this just request responses with HTML? That feels more like we shouldn't be scripting this much. When you're when you're uh when you're writing an HGMX app, scripting in my mind should be like salt. Like a little bit here, a little bit there, but you don't want to dump the whole salt shaker into the meal because that's not how it's designed to. It's just not what it's for in this world. And so you should be using scripting sort of around the edges and to add some interactivity here and there. But you don't want it to be like the crux. I tell people, because HTMX does have a JavaScript API, and sometimes we'll get people, especially on the Reddit for some reason, who come in and they're like, "Here's my HTMX app," and it's like all JavaScript with a bunch of calls. So like and I'm like, "Whoa, that is, you need to read the book and like we got to get hypermedia in the brain before HTMX is gonna be a good tool for you to use." So, but I don't know. Your readers or your listeners can go check it out on the essays page, hgmx.org/essays. They can just look for Gumroad and you'll see it.
This is to me this is interesting. It's like right now if you learn front end development, you kind of like you're not really told that you can use HTML like raw. Like people kind of assume that like React style, like SPA, like single page application is the only thing, right? Like
Right.
there's no concept of like, oh, you can have something that is not working in this way.
Right.
So you kind of start with this idea that like HTMX needs to fit in like in this kind
Right.
of JavaScript kind of like update stuff.
I know. And it's funny too. I mean, it's just like, this is the web. Like this is what the web was. And like, I don't know. I get some people that are like, "Oh, you're just an old man." And I'm like, well, that's true. I am an old man. But also, but also, like there is like the hypermedia is a really interesting idea. And I hope HTMX does move the needle forward or move things forward to an extent. We're writing academic papers on it and trying to get that into the academy so that there's sort of a record of like this idea of like, if your listeners are a little bit more nerdy and they want like a philosophical idea, what HTMX really does is it generalizes this notion of hypermedia controls, like links and forms. Those are specializations of this more general idea of hypermedia controls. And so there's a paper called from hypermedia controls feral to formal. You can find it again linked on the HGMX.org/essays webpage. It's an ACM paper. It was accepted by the Hypertext conference. And we talk about like, okay, like this is a generalization. Maybe it's not the best one because there's a history with HGMX, and so decisions that I made that I wish I hadn't, and blah blah blah. But the philosophical idea is, let's think about what hypermedia controls are, and then let's generalize them. And so the generalizations that I hit on with HTMX are the triggering event, like what causes the request to happen, obviously the URL that it's issued to and the type of the request, a put or a patch or whatever. And then the last one, and this is probably the most important of the bunch, is where do you place the response? So that idea, like with HTMX, you can issue you issue a request, you get back HTML rather than JSON, and then you tell HTMX via attributes, I want you to stick that HTML in this spot in the DOM and just either replace it or maybe append it or whatever. There's a few different attributes to control that. And that last idea is what's known in the academic world as transclusion. That's been around for a long time. It's called transclusion, and it actually exists in HTML today. But it only works with iframes. So, are you familiar at all with iframes?
A little bit, yeah.
Okay, they're like an old technology. No one uses them because they've got their own problems and they're super clunky. But believe it or not, you can take an anchor tag and you can use a target attribute and give it the idea of an iframe. And an iframe is sort of a web page within a web page, and it'll issue that request and then put the response in the iframe. And so that's an example where even back in 2005, like or one or whatever, HTML had this notion of transclusion. What HTMX does is it says, okay, let's not use iframes. No one uses iframes anymore. Let's just like jam the response into the DOM, and we'll just make we'll let you do it anywhere. And so that in that sense, I think it generalizes these ideas that are already there in HTML, makes it much more powerful, makes it possible to build hypermedia oriented applications or hypermedia driven applications is the term I've tried to use, HDAs, where the user experience is still better than the old world, but you're not getting into all the complexity that is required for sort of React applications. And that's a subjective thing. Like people who are used to React are like, ah, it's easy. So, but I think, we can argue about that all day. So,
Yeah, so how does it look like for students, for example, or other people that are picking up HTMX? Like, do they find it easy or like simple, or on the contrary, because they're so used to like the JavaScript way, they find it weird?
yeah, I think it's harder for people that have only ever known React, and there's a lot of them now. There's a lot of people that have only ever built web apps with React. And as soon as you take that away, they're like, where's my stuff? Like where are all my tools? Where's Shad CN and like all this stuff? Shad CN, Shad CDN, I don't know, whatever it is. Like all these things that are just there in the React world. And there is a terrible simplicity to HTMX. Like, it's like there's nothing, buddy. Like you got HTML, render HTML and do your thing. And so if that's intimidating to you or if that's unfamiliar to you, I think that can really be a turnoff, And I've seen, some pretty good developers who are pretty baked into the React world do that, like come in and try HTMX and they're just like, I don't even know how to start. And so it is a big mental shift. It's a different way of building applications. And I think I acknowledge that while also saying I think it's worth getting to a point where you can see why you might build with HTMX. Like someone who's like HTMX is retarded and it's only for toy projects. Like, okay, like if you're not going to give it a legit chance, then I get it. We've all got a limited time and whatever, but I don't think that's if you have the time and if you're a web developer, like I think I don't want to say it's incumbent on you, but I do think it's worthwhile to spend some time thinking about this technology that's just a crucial aspect. Like your browser is a hypermedia client. You're using it for a completely different thing, and that's cool, and it's great at it, and it's amazing that that works. Like that's fantastic. Like we've got great JavaScript runtimes now, and the APIs are really good, and JavaScript has gotten much better as a language, and that's all fantastic. But it also has an incredible amount of infrastructure baked into it to act as a hypermedia client. And so maybe it's worth learning about that because maybe it's appropriate somewhere, like one suggestion I make to people is, hey, use HTMX for an internal app. Like, that gronky, stupid PHP app that's like crucial for your business, but like no one's touched it in like 5 years or whatever. And it doesn't use React. It uses probably just like forms or maybe some like old jQuery or something like that. Why don't you take that and learn HTMX a little bit in an environment where it's not like, you're not making a huge commitment to it and see if you can make that application better, maybe add a lot of value for your business because that's a valuable application that people just aren't, they're just ignoring, and see how it goes. So I think it's much better. The best experience with HTMX is someone who knows the old way of building web apps and has like an old web app and they're like, oh, I'll sprinkle some HTMX in it. And like you can get so much so fast that way, like active search and like sorting without resetting the scroll state and like infinite scroll and like all this stuff is just like 3 attributes, 4 attributes maybe, and boom, it just works. And so you can get really big wins when you're coming from that world. But I do think, yeah, when people come at it with like sort of React brain. And I don't say that as a derogative, like that's just, the way it is. Like I've got hypermedia brain. Like I go and look at React and I'm just like, what is this? I don't get it. So I've got hypermedia brain. You've got React brain, and it's going to take a little bit to get, to get the plasticity necessary to understand the hypermedia approach.
Okay. You probably have seen a lot of the same apps first, like in React and then in HTMX, or the either way, right? What would be the most glaring differences?
The focus on the back end in the HTMX apps, like the lack of code for the front end. Like with a React app, typically your front end is a lot of code and then your backend gets dumber, gets smaller. Like you've got APIs, and I think some backend people like that because they're not responsible for very much. It's like I just produce an API and like, maybe like I try and like wedge, GraphQL or something in there and then deal with all the security issues or whatever. Like it just simplifies the back end to an extent to just have this generic JSON API. But also, I think when you build web apps in that world, and you've seen this, like people, I think it's back end for front end. I forget exactly what the terminology is, but there's people have observed that it's often not good to have your general purpose API for your web app. And so you often create either a second API that's for your web app or a JSON API, or you start adapting your JSON API with like special endpoints that support your web app. And I think there's a tension there when you build like that. If you're trying to have a general purpose API and a web app API, because for your web apps, just like all applications, they tend to be really fiddly. Like I've got a UI and it needs this data, and I want to make one request and just get all that data. I don't want to be
Yeah.
chatting with the server a whole bunch. And so there's and that pushes you towards a more specialized API driven by your UI. So that I think is another thing that you'll see in React apps or any app where you've got a what hopes to be a generic data API in the backend. It's going to feel that pressure to adopt more specialized endpoints, either as a separate API, excuse me, or as a specialized endpoints in the existing generic API. Whereas with HTMX, what you're going to see is very little code on the front end, and then a back end where the API is incredibly specialized for your front end because the backend API is your front end. You're delivering your UI as hypermedia to the web app, like on every request. And then if you do have a JSON API, that tends to be a separate thing. It's like it's not talked to at all by the endpoints that are returning HTML. And there was an attempt, I don't know, how old you and your listeners are. There was an attempt in the Rails world to make the HTML endpoints and the JSON endpoints the same. And so your web app, you would use the content header and you might render as JSON or you might render as HTML. And that has appealed to web developers, I think, for a long time. But what I've noted, and there's an essay up on it on htmx.org/essays, what I've noted is that I think those are separate. They're separate things. Like a generic data API and your web app API, they just have these different tensions. Your generic data API wants to be stable, regular, probably rate limited, and like all these things that like don't make sense for your web app but do make sense for general data consumption from third parties or maybe your mobile app or whatever. Whereas your web app, again, I'll say it again, like a web page, the ideal request cycle for one view is I make one request, I get the whole view, and I render it,
Yeah.
and that's it. And you can do that in JSON, obviously, but you can also do that with HTML, right? With HTML, you can just do all the queries you want on the back, joins and like group bys and all that SQL stuff to just have one thing, and boom, here it is. And that's sort of fundamentally the way the web can work or the way it worked. And so you get that nice sort of like one request for one UI behavior if you adopt HTMX or the HTMX style, sort of hypermedia driven stuff. So, but to get back to your original point, like I think the big difference that you're going to note immediately is that there's just a much smaller front end code base. Like your templates, if you're using templates, are going to be much smaller. There's going to be significantly less JavaScript code because you're effectively stripping out a layer, right? Like in an SPA, you have the DOM, you have maybe is it the virtual DOM, VDOM? Someone got mad at me on Twitter because I confused Shadow DOM and virtual DOM. I'm going to say whatever makes him mad. Whatever makes that guy mad. He said he watched 500 times. So I'm going to use the wrong term here. So you've got that. And then maybe you even have a model behind that. Like if you think about it, right, you might even have a JavaScript model sitting behind that. And then you've got stuff over on the server and you're trying to synchronize like all of this state. And with HGMX, you collapse that down to just the DOM and the server. And so these layers just sort of like melt away. And that comes with trade-offs from a usability standpoint for sure. But it also simplifies code bases tremendously. That's another thing that I think you would see in most cases. And there's an example on the HGMAX website, a real world port from the React HGMAX, where they saved basically like 2/3. The code base went down by 2/3 in size. So like it was a third the size of the original one. And that was sort of a best case scenario, I think, for HTMX. The style of app that they were building was a very media heavy. It was pictures and images or images and text, I should say. So it was a style of application that was very amenable to HTMX. But they obviously, they saved a tremendous amount of code by doing that. And I think there are a lot of apps that would benefit similarly. Not all of them. I think you have to be reasonable about your expectations. But the more sort of cruddy and the more value your app adds on the back end rather than the front end, the more I think the HTMX approach is beneficial. So.
Yeah. And it, like you mentioned, that the best case scenario is like right now, even if you have JSON API to get this like one big payload for one, because then you just render the stuff. But it's rarely the case now. Even like you usually have, like, if you look into developer console, you have like, first response, which is like kind of like a layout ish, and then you have like this widget, this widget, this widget, this widget. So like you look at those requests, and with HTMX, you kind of a little bit forced, like, or at least guided to sort of make this into a one web response. Like, here's your response, here's the HTML, just render it, right?
Yeah. For sure.
Okay.
I think, and you can do the same thing with HGMX. It's not like you can't make a bad chatty, experience with HGMX, but I do agree with you. I think it pushes you away from that, like just naturally. Whereas in React, I think, or whatever, a lot of those requests aren't happening directly at the behest of the user. They're happening because of second order effects. Like you update something and a request gets generated, or you load a list and then like a bunch of requests get generated, and you're not being explicit about that. You're just saying, I just want this list to render. But then underneath in the muck down below that ends up causing a bunch of requests to happen. And that's one thing that I really like about HTMX, is that it strips away the network abstraction. Like that you see it. Like I'm making a network request right here, and I'm going to get back the response, and I'm going to put it right there, and that's it. And there's something valuable about that immediacy and that locality. Whereas like it might appeal to our more, sort of philosophical sides. Like I just want to update an object, and then whatever the UI has to do to make the UI look right is good. And there's something magic and appealing about that, to like a programmer, but there are trade-offs with that. Like when you take the network, the explicitness of the network out of that loop, the developer doesn't see necessarily the ramifications of what they're trying to do. And then they can't tune for that as easily. And so I think you develop you can develop more network sympathy, like understanding, like, wait, this is a distributed system. I'm making a request here. I need to show an indicator. Like that stuff's all baked into HTMX, and I think that's good. It's lower level than a lot of approaches, but I think it's also not necessarily a bad thing for it to be low level like that, because you just see it like, okay, this thing's making a web request, and if that thing takes 7 seconds, then this is going to suck. So I need to make it not take 7 seconds.
Okay. Well, in terms of HTMX implementation, right? Interestingly enough, you needed a whole bunch of JavaScript, like that you kind of wanted to get away from to implement it, right? Is there some sort of interesting systems lying underneath that you want to highlight or talk a little bit about?
So I've got a video where I walk through the internals of HGMX, and I have to say at this point, like the internals of HGMX are I don't think I'm not going to say the internals are bad. They are what they are. There's a lot of functionality in HTMX that I think is more complicated than I would like. But if your listeners want to go to htmx.org/essays, there's a deep dive video where I go through and I just walk through it. But like at a super high level, what HGMX does is when you load the library, it looks for these HX attributes in the DOM and then just hooks up event handlers based on like, okay, is there an HX trigger? If yes, like, does it have any modifiers or whatever? And like hook up an event listener. And that event listener then just says, okay, when that event happens, I'm going to issue an AJAX request and I'm going to get back HTML. And then again, based on attributes, I'm going to like you set the inner HTML or the outer HTML of some element. So the fundamental idea of HTMX is pretty simple. And then the last, I think one important sort of like detail there is that new content, when it's inserted into the DOM, we turn the crank and we look for HX attributes in that new content. And so that's how, like, when new content with HX attributes in it, that's how it gets hooked up, is it's processed when we hook it up. And that's why if you mutate the DOM externally to HTMX, you have to call a library function on HTMX, HTMX.process with that on that new content, and it'll go through and hook up any like listeners that are necessary. So there's not a lot of magic to it. But I do, there's another project, like I think early this year, I was like, you know what, I'm just going to do the simplest possible version of HTMX because I'm so sick of dealing with like all the decisions. And yeah, a lot of them are like, there's a lot of good, like, it's easy to look at code and be like, this is so ugly and stupid and so overly complicated. But there's a lot of stuff in HTMX that's there because of like quirks in the HTML or in the JavaScript APIs and the way the DOM works and stuff like that. But I did earlier this year go and knock out a project called Fixie.js. So you can look up Fixie.js, and Fixie.js is sort of like my stripped down bare bones version of HTMX. And I think it's like 90 lines of code compared to HGMAX, which is thousands of lines of code. And now a lot of that's comments in HTMX, but nonetheless, like Fixie.js is like an absolute minimalist, and it doesn't have nearly the bells and whistles, and it doesn't handle all the corner cases that HTMX does. But if your listeners want to go look at like what's the core idea of HTMX, what's the core idea of
Yes.
generalizing hypermedia controls, they can go look at that. And that library, it's designed to be copied and pasted and then maybe even modified by end users. Like it's designed to be so small that anyone can understand it in like an hour. And like it has no dependencies, it has no nothing. It's just a raw JS file that you can copy and paste or download or whatever. So, and I think that really, like, there you can very much see, because it's so small, you can see like this is what it's doing. It's looking up this attribute, it's looking up this event handler, and it's issuing this request, and it's doing this with the response. And so it's very obvious there. So maybe if your listeners don't want to deal with the insanity of the HTMX code base and all the like crazy corner cases that deals with, then they can go look at Fixie.js instead.
Okay. Okay. Fixie.js. I want to ask you a little bit about the mobile version of HTMX. What
Yes.
changes? What changes? Why there is a need even for like a new different library, right? For the
Yeah.
mobile.
Right. That's Hyperview, which so our book, the book, I think you referenced it earlier. We have a book called Hypermedia Systems. And you can read it online for free at hypermedia.systems, or you can there's a hard copy version, there's a softback. They've got pretty sweet covers, and you can get digital versions of them as well. I also, just for your listeners, I uploaded it to LibGen, so you can go and download it from LibGen if you want for free. So it's available wherever you want. But in that book, it's sort of split into thirds, and I think the first third would be valuable, even if you don't care about HTMX. The first third would be valuable for any listener who never has built, or maybe just hasn't for a long time built, a Web 1.0 style application, because I walk through and talk about like the concepts of hypermedia, and then Roy Fielding's dissertation, which is really important from a theoretical standpoint, and then go through and just build this, very simple contact application in the Web 1.0 style in the first third of the book. And I think that's really good to like see, oh, this is how the web works. Like this is how the web worked, anyways, and get that sort of sense of like, historical perspective. And then the middle third is taking that web app and improving it with HTMX, sort of that style of development that I talked about earlier, where it's like, let's take an existing Web 1.0 app and make it better with HTMX. So that's the middle third. And then the last third is what you asked about, which is like this mobile system called Hyperview. And Hyperview is a mobile hypermedia system. It's an entire system. It's not just hypermedia format. And you actually have a hypermedia client that you build and that you deploy as a mobile application. And then it speaks a dialect of XML that's a hypermedia called Hyperview, or HXL, I think, HXL. And the advantage of that system is it allows you to take advantage of native mobile metaphors and UI experiences. So like swiping and like all that stuff is like baked into the hypermedia. The hypermedia knows about those events and knows how to like draw things properly, and it sort of like does layouts the right way for mobile without you having to do anything special. And so that is it's a mobile hypermedia. Again, it's hyperview.org, I think. And that was created by a guy named Adam Stepinski. And he created it because they had a web app that he works for a company called InstaWork in San Francisco. And they had created a web application and they were using Intercooler, the older version of HTMX. And they loved developing with it because they were able to develop really quickly and they were able to ship new features really quickly. And Adam was I think the director of engineering there, and he noticed like our web app, like every time we want to make a change, we have to go and get it approved by Apple and like deal with Google and like all this crap. Like this stinks. If only our web app, or if only our mobile application could have this great sort of like feature of web apps where you just get the latest version. You don't have to update in the store. You don't have to update. You just get whatever the latest version is. Again, that's one of the great things about hypermedia is you're always on the latest version of the app because you just asked for the UI. So he built a hypermedia basically specifically for mobile, and now they use that for their mobile application, and they have that advantage. Like they don't have to get Apple's approval every time they want to add a field to a
Yeah.
UI. They can just put it in the response from the server, and the mobile hypermedia browser that you use. It's a little bit different than a web browser because it's specialized just for your application. But it still has that same concept of like allowing the hypermedia to drive the UI rather than having the UI hard coded in the mobile app itself. So that's why basically, like, I think that's the big value add is like I don't have to deal with Apple and Google every time I want to add a field
That's awesome. That's
to my
awesome.
mobile application. Yeah, like I've said this before, but I think Hyperview is much less popular than HGMX because HGMX is just the web and like there's so many web developers. But I think from a technical achievement standpoint, Hyperview is far more of a significant technical achievement than HTMX is. With HTMX, like I think the idea of like, okay, generalized hypermedia controls, like I think that's a good intellectual contribution. But as far as just the ambition and like what I actually had to do to make it happen, Hyperview is just like, dude, that's crazy. That's like a whole it's its own hypermedia system where I just piggybacked on the web, which is already obviously very successful. So
Yeah, because they needed to make the browser, right? The client
yep,
itself, and then kind of like
exactly.
define the protocol a little bit
Yeah, they
to
define their own
fit.
format. They did leverage like HTTPs, obviously what they use in them. So there's stuff there that's like already there, but they define their own hypermedia format, and then especially getting that client right and how that all works is like that was very, very cool. So good stuff. Adam's a very smart guy and very nice. One of the nicest guys I've ever met. So
Nice, nice, awesome. I wanted to talk a little bit about sort of like I wanted to move about to sort of opinion corner and
okay,
your thoughts on programming.
yeah,
You mentioned the idea of coding dirty as a sort of opposition to clean code, which
yeah,
the more I program, the more I hate the abstraction layers that we're dealing with. Like at
yeah,
this point, like anytime I want to look up something, the behavior of something, I need to see like 17 files to
yep,
even like and then like remember all of them together.
yep,
And I feel like at some point there were like huge C and C++, maybe even Java like applications that were with like 1-letter variables, and there was this book Clean Code written to address these issues. And now we're like on this far end of like over optimization on and it's just like we need to find a balance. And I think that you have made the coding dirty sort of 3 rules, right?
Yeah.
Could you highlight them a little bit?
Yeah. So clean coded, coding dirty is an essay again on the HGMX.org website. And I have essays on hypermedia, but also just on coding in general. And I think it's a response to exactly what you're getting at, what you're talking about here. There's clean code, which is this idea, particularly one thing that really sticks out at me in clean code that I don't like is that functions should be small. Like, I don't agree with that at all. I think functions can be small. I think that sometimes that's good. But I also think functions can be pretty long. And if they do something complicated, I don't think you should break it up just to break it up. I think if there's code reuse to be found, then maybe you start breaking things up. But so I think, what are my 3 rules? So first of all, I like big functions, and I cannot lie. I think that's I think big functions are fine and sometimes good. What was the other? Hold on, I got to look it up.
I can. So you mentioned the tests, unit tests.
Yeah, tests. I tend not to use test-driven development where I write unit tests in particular. So I almost never, I would say, almost never write a test and then write one function and where that test just exercises just that function and like looks at inputs and outputs, like that, where that function doesn't call anything else, like mocking out all the dependencies and all that stuff. I tend to write higher level tests. So all, and it depends a ton on what sort of code I'm writing, but I will often write what I would call integration tests. So like, I do a lot of like programming languages and like systems type coding. And so I'll write a test that's sort of like, here's a string and here's what I expect to get back when evaluation is done. And then I'll have that test, and that's going to go through like a tokenizer and a parser and maybe an eval. Like, that's going to do a bunch of crap, but I'm going to write that test, and then I'm going to write all that stuff, fill it all in. And then when it finally works, I'm like, great, it works. And that's amazing. And it's test driven to an extent, but it's not unit testing. It's not that unit test. It's a very high level test. It exercises a lot of code. But what that intermediate test does, in my mind, is it expresses an invariant about the system that's at a much higher level. Like, I can have a tokenizer that uses like characters, or that maybe does something like crazy with like code points, like whatever. However the tokenizer works, it does what it does, and I don't care. And however it hooks into the parser, it does what it does, but I don't care. My test expresses something that's going to be true regardless of all that junk. And so it's expressing something that's going to be true forever, I hope, unless I change my programming language. And so I love those tests because I'm not committing to any particular implementation. And that's what I dislike about people that are very focused on unit tests, is that you end up with lots of tests of your implementation and not of these higher level invariants of what you're trying to achieve. And then what's bad about that, the reason that's bad, and they would say, well, if you change your implementation, just throw the tests away. And that's easy to say when you're one guy working on a project and what tests are good and what are related to what. But the reality on the ground, in my experience, is in big teams, test suites tend to develop their own momentum and weight. And so if you have a bunch of tests for a particular implementation, and changing that implementation is going to break thousands of tests, and you don't know which ones are real breaks and which ones are fake breaks, which ones are just because you're doing things different, it's gonna lean on you, and you're gonna be less inclined to make that change, even if it's a good change. Whereas if you have these higher level invariants about the system expressed, you're gonna be able to make that change without breaking that test, because it's expressing a higher level truth or invariant about the system. So my experience with test driven development, and particularly that focus on unit tests, is that you tend to accumulate a lot of implementation tests that are really fiddly. You end up writing a lot of specialized test code to like mock things out. Like, whenever you've got a lot of mocks and like stuff like that, like a bunch of test infrastructure, that's just stuff that's now leaning on you and making it harder to change in the future. And so in general, that's why I tend to lean towards higher level function, higher level tests, and what I would call integration tests, end-to-end tests. And you can make the argument that my example was an end-to-end test. They start to get they're hard because they get too far away from the implementation. So like the classic example there is like web tests. You've got some test that pokes your website and then asserts that some text is found after you pressed a button, right? That's like the classic end-to-end test. And the problem with that is like it breaks. And why did it break? Did it break because like you changed the text, like you changed a label somewhere, or like maybe you restructured the UI to be slightly different, or maybe there's an asynchronous aspect to it now that's like all this stuff where it's not a real break, but it's real hard to figure out like why didn't this do what I expected it to do? And that's the downside, is you sort of like on a continuum move away from the implementation and up towards like these more general truths as you get further away from the details, and it can get harder and harder. So in my mind, the sweet spot is sort of those integration tests where you exercise a fair amount of code, maybe the public API for a particular module, if you want to think of it that way. But you exercise a fair amount of code, but you express these higher level truths. You can still sort of debug it and sort of see where the breaks are fairly easily because you're still down in the muck to an extent, but you're up above the unit tests. So that's the unit test thing. And then the last one that I remember is I think classes can do more than one thing. I think, and this gets at what you were talking about, I would call it over decomposition. I think that developers are prone. We like abstraction. That's like how how we deal with everything. We just abstract this. Like, listen to me. I'm going to abstract hypermedia controls. Um, but the that's not a cost-free operation. Anytime you introduce abstraction, you also make it harder. Particularly if it introduces a new concept. That's something that people have to deal with. And you were talking about earlier, like, why do I have to deal with 17 things to do something? And I think that gets at this problem that we have sometimes of over decomposing problems. And, we don't want things, what's the classic cohesion statement? Things that change together belong together. And like, if they don't change together, maybe they don't belong together. And I think that's a good, that's a good rule of thumb. But I also think we developers need to be wary sometimes of our tendency to over decompose. And for example, introduce dynamic dispatch in an object-oriented programming language rather than just using an if statement. Like, just write the if statement. The if statement is fine. Like, if this and then this, otherwise, like, that's so easy to understand and debug, and you don't introduce like an interface and all this other junk that you do if you start trying to use dynamic dispatch for that. So that's I think where I'm trying to push back a bit. Like, I've really, and this is, I push back on myself sometimes. Like, I'm like, oh, I need to like pull this out and like make it its own thing. And I'm like, wait a second, Carson, like, don't do it. Just put the if statement in here and like wait and like give it some time and see. If it gets really big, then maybe there's something there. But like if it's 2 or 3 if statements, like that's probably okay. And it's way easier to understand 3 if statements than it is like a whole object model for this thing, which, I program in Java mostly. So that's my tendency, is like, I'm just going to introduce, an interface and a blah, blah, blah. And that stuff's just, it's not cost free. And so I think that's like even if you disagree with me on exactly where the line is, I think the thing that I hope you would take away from some of my writings is that these things that are presented as good, and they are good to some extent, they're not cost free. Like, anytime you introduce a new file in your code base, that's one more thing and one more place that people have to like go and understand sometimes. And versus just leaving an if statement and a method somewhere, like maybe that if statement isn't so bad. So
Why do you think you mentioned that like you kind of need to pull yourself back a little bit and
yeah.
like fight with yourself? Why do you think this is sort of the natural tendency? Because it seems like Uncle Bob capitalized on our like developer's natural tendency when
Right.
writing the clean code, right?
Yeah. Yeah, and also our tendency to be like the other guys are wrong. Like, like I'm so much smarter than those people write dirty code. That's one reason why I picked that title. Is like there's like a moralism to like who how could you object to clean code? It's clean. It's like, well,
Yeah.
I don't know, man. I just don't like it that way. So but I think, we're developers. If you're good at developers, you're good at abstraction, right? Like that's you to just like we make things up in our mind and then they happen on the screen. And so and you just I think being a computer programmer selects for people who are they have a tendency towards and an affinity for abstraction. And so we just have to be disciplined about that. And there's a website called grugbrain.dev. I don't know if you've ever read that, but that's a website that I wrote, kind of a joke, like my humorous take on software development. And I talk about how computer programmers, like we're all inherently Platonists. Like we go and when we look at any code that we're not familiar with, we're like, this is garbage. Like look at this if statement and like I can't believe they're checking that. And like this doesn't belong here at all. Like, why is this Boolean here? This has got nothing to do with it. And that's just how we are, because we're like, we should just gotta separate it all out and make it clean. And our food is like our peas are here and our potatoes are here, our steak is here, or whatever. And I think we just have to fight against that and recognize like the world is messy. And sometimes, again, I would just go back to that statement that when you introduce indirection, which is what typically the tools of abstraction are, is indirection, like I'm pulling out an interface or I'm introducing a new type or whatever it is. That's not cost free. Like that has a cost associated with it. So there better be a pretty good benefit associated with it. So, I think it's just the nature of programming. Like, the Dijkstra wrote a really good essay on like, I think it's called On the Cruelty of Teaching Computer Science, about how computer programmers live in a world that goes from like billions to like ones. Like we have like the scale that we have to operate at conceptually when we're programming. Like you have to know, web development, it's so easy, right? Okay, CSS is the hardest thing in computer science.
Yeah.
CSS is the hardest problem in computer science. I'm a professor. I'm allowed to say that. Okay. You guys think like web programming is easy? Center some text vertically, right? Like, and don't look it up you can't use Google. Like, good luck, kid. And it's just crazy how complicated that is. And like, oh, you have to know like what colors are like, what RGB colors are. And like this is like super low level to super high level, like craziness that we have to deal with. And I think that just means for us, the only way to deal with as much complexity that we face on a day-to-day basis is with abstraction. And so we have this natural affinity for it. And the only thing that I think that's good, and abstraction is a good thing, it is how we manage all this complexity. But we also have to check ourselves sometimes because it's not cost free. Like those abstractions aren't cost free always, and sometimes they hurt more than they help. So
Okay. Do you think over the years have you got some of the lessons uh, in terms of general software engineering that you could like kind of pull out from your experience and then share as a sort of like a nuggets?
yeah, I think grugbrain.dev is that is
Yeah.
exactly that.
Okay.
So your
Okay.
listeners can go there, but the high level ones that I'd say from there are like, so one thing that comes up when you talk about software is like accidental versus and necessary complexity. Is it necessary? What's the term I'm thinking? Incidental versus necessary complexity, I think is what the terminology is. I just signed a paper on this and I've already forgotten it. Getting old sucks, man. But anyways, like there's complexity that's inherent in the project, and then there's accidental stuff that's like it didn't have to be this way, but it just because we picked C, now we've got to deal with memory management, and if we had not picked C, we wouldn't have to deal with memory management, some stuff like that. And I think that's true. There is a distinction between these two types of complexity, but I think you can control inherent complexity by saying no to features, not just to like external people, but also to yourself. Like I wish I had said no to features in HGMX at times, because HGMX is more complicated than it needs to be, because I wasn't willing to say no to some features that sort of like came in. And so people, I think, can sometimes sort of suggest that, well, they can justify things in terms of inherent complexity or, necessary complexity. But I think you can control that too socially by either saying no or by making it okay in an organization. Like, say no if this is too complicated. Say no if this is too complicated. So I think that's a big lesson from my life in general. And again, I do as I say, not as I do, because I screw this up all the time. Um, Other big things, I think, and this is, if your listeners want to read a book, there's a book called A Philosophy of Software Design by John Osterhout, who's a professor of software or of computer science at Stanford University. And that's sort of his take on software engineering. And it's a great book, pretty short and a good read. Um, and one thing he talks about in that book is the value of prototyping and like getting something that does something as quick, getting to something that does something as quickly as possible, so that you can show an end user and be like, okay, is this doing like kind of what you want? Yeah, it's way too slow. Okay, but it's doing the right thing. Okay, because all the UML in the world is not going to answer that fundamental question, like, am I doing what the person wants me to do? And if you sit around doing like architecture diagrams and like all this crap, and you build this castle in the sky without that rooted, like, let's make a computer do a thing for a person, click a button, do something useful, then I think you can get into trouble. And I've seen that many times in my career. So that's another lesson. Um, if you're designing an API, layer it, like make it so that doing easy things is easy and doing intermediate things is like intermediate and doing hard things is possible. So, like an example I give is like reading a file, like this, I think, is a good example. Like when I read a file, I want to call file.read. I don't want to new up a buffered byte stream or whatever. I want to call file.read and I want to get a string back. That's what I want typically. And sometimes that's bad because, the string can't fit in memory and there's a 2 gig file and now like you're, out of memory or whatever. So, okay, let's acknowledge that. And then let's also add like a file.read line that maybe takes a callback, a closure or whatever, that like emits a line. So now, like, okay, I can still like work with it as a string, but I can do it a line at a time and I can deal with these really large log files. And so maybe that's like my intermediate. Now I need to know what a closure is and what a callback is or whatever. And so that's a little bit more complicated than just file.read. And then, okay, now I'm in this world where I've like really got to get into the muck and I want to use buffering, like, optimize my buffering size and my window size and all that stuff. Like, okay, now there is an API for me to get down into the muck with that and specify, like, I want you to read like X bytes at a time because I know that's the right memory size for my access pattern or whatever. And I should have that API, but that shouldn't be the default API. And like, if you look at Java, the way the Java, that's what I program in for the most part. That used to be the default API. Nowadays, they've got better APIs. They put them in random places so you can't find them.
Yeah.
But the better APIs are around. You just have to like dig around to find them. But I think that idea of layering APIs and making the easy thing like dead stupid simple. Like one technique I tell my students when they're designing APIs is like, okay, think about what you want to do. Like, I want to read a file. Okay, find the file object and put the read method on it and like have it return a string. And like that's good API design. That's like what you want to do. You don't want people to have to learn a bunch of concepts to do stuff like this. Like, you don't want to introduce a complicated object hierarchy or a crazy API with all these options. They don't know that, like, pick a good default, and like make it possible for them to configure all that stuff, but don't force them to learn that. So I think that's another lesson in my life and sort of like thing that I push. Greg Brain has a section on that. So
You say that a new input stream, new file input stream, new
new,
whatever
I
something
know,
stream is not a good API.
no, I mean, it can be like sometimes you need a custom stream implementation, and so like maybe like that's necessary, but that's the streams, like there's a like classic, like patterns are bad. I think patterns have been a net negative for the Java community. Like, I hate to say it because I love Christopher Alexander? Christopher Alexander. The guy who did that, he was an architect. I wish architects had listened to him and software developers had not. It was like exactly backwards. Like, that guy, he was an architect, and architecture sucks because the architects won't listen to him. They keep building just garbage boxes, and like ignoring the lessons of history. But then software developers like took his ideas and were like, oh, this is great. Like, there's these standard patterns, and we ruined software, at least Java software with it. And it's like, man, that sucks. Oh well. Yeah. So architects, if you're an architect listening to this, like a real architect who builds buildings, read Christopher Alexander's stuff and internalize it. And if you're a software developer, ignore the patterns stuff for the most
So
part.
you don't like design patterns then?
I I think they tend I think net they have forced over engineering on particularly the Java community, which I have the most
Yeah.
experience with. I think patterns tend, when you think about patterns too much, you tend to over engineer and over abstract and maybe over, decompose problems. So, yes.
And if you said that you program in the J2E world, like
J2E.
if like with this plus design patterns to extreme,
Oh,
it's just like
it,
oof.
yeah,
Oh boy.
it was so bad for so long. And it took me a long time to gain the confidence to be like, you guys are doing it wrong. Like, I talk about this at the end of that Grug Brain essay, the fear of looking dumb. One reason why I think these just crazy complexity, like these crazy complex ideas end up persisting for so long is that everyone's afraid to say like this is so overly complicated for what we need, because that sounds similar to saying I'm not smart enough to understand this. Like it's those two things sound like one another. And so we as developers, like there's nothing more fatal to our careers than I'm not smart. And so it's very hard for us to say anything that sounds even close to like, I'm not smart. And when you say something like, dude, that is way too complicated, they're like, oh, you're not sophisticated enough to
Yeah, yeah.
understand my, and it's like,
I
no,
see.
dude, you're just over engineering this. And so we really, I think as a profession need to grind on that and make it okay. Like being super complicated, there's, oh shoot, blanking on his name now, the Pascal guy, Worth, Nicholas
Nicholas
Worth.
Firth, yeah.
Nicholas Worth, right? He's got a great quote and he's like the smartest guy who was around for a while, like one of the smartest guys, like built his own computer, built his own compiler, built his own operating system. Like he was like, oh, we don't have those here in Europe. I'm just going to build one then. And he just built it himself. It's like, dude, that's, he's a
Yeah.
stud.
He
And
passed
he
away
did. Yeah,
2024, yeah.
he did. And he's got a great quote, which is like, to summarize it, I'm not going to say it as wittily as he did, but he was like, complexity should inspire suspicion, not admiration in us. Like we shouldn't be looking at complex systems and thinking, wow, that's really cool. We should look at it and be like, why is that so complicated? And if someone that's smart, if someone as smart as that guy, the creator of Pascal and Oberon and all that stuff, can think like that, then I think we all as programmers can think like that. Like we need to look at things and be like, why is this so complicated? Now that doesn't always mean we're right. I've had plenty of experiences where I've gone into a code base or an API and I'm like, this is way too complicated. And then a week later, I'm like, okay, I get it. Like I get it. I see why. But especially with our own code, I think that just that instinctive, that's one reason why in the Grug Brain essay, I say complexity bad over and over and over again, is this mantra to just push back against this tendency towards complexity. You'll get people like, well, what does complexity mean? Like define complexity. And I'm like, dude, I'm not going to do it because it's not doable. We've been trying now for, 100 years to do that. And we've not come up with a good definition of software complexity, or 50 years, call it. But nonetheless, like we need to be saying complexity is bad. Like, am I being too complicated here? And I do that a lot in my code now. Like I've deleted a lot of code that I've written because I'm like, nope, this is too much. And I'll just back it out and try something else and see if I can like come up with a simpler way to do things, or not do something like I'm not going to handle that case. I'm deleting that code, and I'll throw a reasonable exception or whatever, but I'm just not handling that situation. So that I think that's a really important thing for us as just software developers, as a profession or as a guild or whatever you want to call us, to like, it's okay. Fear of, what I call it in the essay is fear of looking dumb. Like, don't have a fear of looking dumb, because that is why a lot of horrors are inflicted on code bases, because no one's willing to speak up, because they don't want to look like they're too dumb to understand what people are doing.
On that note, do you think that the software is in decline now?
Um, I think we're entering a silver age. I think we had a golden age, and I think we've probably been in a silver age for a while, where new things that we're not moving the needle like we did. I think the golden age may have ended in the 80s. Like, when you go back, like, what are the big jumps in computer science? Like, functions, like the function abstraction, like that was a massive jump.
Yeah.
Just like you went from like assembly and like down in the muck to like variables and like function calls, and that abstraction was such a massive jump forward. And then garbage collection, I think, was a similar, like, this idea you don't have to manage your own memory, like the computer will do that for you, was another big jump forward. The web from a distributed system standpoint was another really big jump forward. And there were, like relational databases and all that stuff. I think in the last 20 years, there's been less significant developments like that. It's been more just understanding those tools. And I would call that a silver age. I don't mind silver ages. I like them. I like polishing and like kind of like, a lot of like HGMX is pretty much done as a library. There's polish to add to it, but I'm not going to revolutionize what hypermedia controls. They are what they are. So I don't mind that. But I do think we're in a little bit of a silver age. And if you look at it and compare it with the past, honestly, we're not in sort of that golden age where, like, you take the computer from 10 years ago now, and it's a pretty good computer. Whereas you go 10 years ago and you take a computer from 10 years previous, and that's a pretty crappy computer. And if you go 10 years previous to that, like, it's not even a computer. It's like some other thing. It's like just it's a 16-bit. 10 years earlier than that, and it's the size of a refrigerator. Right. Like, so like there's something like we definitely, in my mind, entered like more of a silver age. And I think that's can be hard on people that want that heroic golden age sort of like feel. Like, there's a lot of money that was made and blah blah blah. But I don't mind silver ages. Like, I like, grinding and like preserving the best of the past and taking those ideas and integrating things. I think that's right. That's one thing that HGMX is it's taking new ideas like Ajax and like integrating older ideas like hypermedia into it and sort of mixing it up and coming up with something that's better, but not like revolutionary necessarily. So yeah, so I would say we're in a silver age, which is still a good time. At least it's not an iron age yet. We'll get there, but silver ages are good too.
We'll get there. Nice. So what's there in the future of HTMX then? Do you have something on the roadmap?
No, I think HGMX is pretty stable. Like, there's an essay called "The Future of HGMX" on the website, and
You have
I don't
essays for everything.
because whenever anyone asks me a question, I'm like, I'm gonna write an essay about it, and then I have that, and I can just point to it when
Nice.
people ask me questions. So, it's a good way to go through life. But I think HTMX is going to be really stable. Like, that's what it's focused on. It does what it does. It generalizes hypermedia controls, and so we're gonna clean up the bugs as best we can and introduce config options where there's like mistakes that we made or defaults that some people don't like, so they can flip a switch and have it behave differently. But we're not going to make any big radical changes to it. I'm working on other software like right now, so I'm working, a lot of things that I hope I can sort of release by the end of the year. I've got a scripting language called Hyperscript that I need to get to 1.0. So I'm working on that. That's inspired by HyperCard, that system that I talked about earlier. It's a scripting language for the web. So a lot of little things like that, but I try to leave well enough alone. I don't, it's bad from a marketing standpoint because people are like, is this project dead? HTMX is just a meme. HTMX is dead. And I'm like, well, so I try to act like erratic online. My online behavior is very erratic in order to draw attention to my stable unstable libraries. There's like, when you've got like a really unstable library, you can like wear like black turtlenecks and be like Vercel and like super like, well produced. But when you have a very stable library that doesn't change, you have to act like a lunatic to get any attention. So that's good. Good thing I'm good at that. Thankfully I'm good
Yeah.
at that.
Yeah. Twitter is much more funny and positive place with you around,
Good.
I
Well, I
must say.
appreciate that, especially the positive part.
Yeah. Okay. Thank you so much, Carson.
Yeah.
This was lovely
Yeah.
discussion.
Good. Yeah.
Thank you so much.
Yep. Absolutely. Have a good one.